we present a software for training new anesthesiologists using Microsoft Kinect in ultrasound guided needle placement. For developing the software, we refer to a paper written by Dr. D. Maggie et al. Called an augmented reality simulator for ultrasound guided needle placement training. In their work, they had used a magnetic motion tracking hardware for detecting the position of the probe and the needle in 3D space. In our work, we are using the Microsoft Kinect instead of the magnetic motion tracking system, as the Kinect is much cheaper than the magnetic motion tracking system, and it provides a decent accuracy for the motion tracking. Let us look at some of the concepts involved in the software. First, motion tracking. Using Kinect, we capture the raw color information and depth information of the scene. We have 3 color markers attached on the probe and the 2 color markers attached on the needle. Using these color markers, we identify the position of the probe and needle in 2D space. Then, using this information and the depth information, we query the depth viewer and find out the third dimension of both the probe and needle. The second concept involved in our software is the construction of volumetric data. Real ultrasound images of the femoral nerve along the transverse direction were captured at the Hospital of University of Pennsylvania. Based on these images, a 3D volumetric data was constructed. Linear interpolation was used for determining the density values of the locations in space where image data is not directly available. The third concept involved in our software is data visualization. Ultrasound allows anesthesiologists to accurately view the position of the needle tip placed within the body. Our software tries to create a similar visualization. Based on the position of the probe returned by the motion tracking module, we perform real-time slicing of the volumetric data. And if the slice plane is the same where the needle is present, then the needle is also shown in the image. Thus, the doctors can see the position of the needle tip within the body. Let us now see a demonstration of our software. On the left hand side, there is a video which shows a person actually handling the probe and the needle. Please note that it's a mirror image. That is, the left hand is the right hand of the person and the right hand shown in the video is actually the left hand of the person. On the right hand side, we can see the ultrasound images generated by our software. As you can see, there are little red markers in the video part. It represents the position of the markers detected by our system. On the right hand side, we can now observe ultrasound images generated by our software. And with changes in the position or orientation of the probe, the image generated by our software also changes. The bright grey line which can now be seen is actually a visualization of the needle. As you can see, the needle sometimes appears in the image and is not visible at other times. This is because slight changes in the position of the hand removes the needle from the slice plane and thus it cannot be shown in the image. This actually simulates the real ultrasound device, which is also very sensitive. Right now, needle visualization is not that much refined, but with little more time, I am very sure that the quality of the software can be drastically improved in terms of needle visualization. One of the key findings in our research is that the accuracy of the Kinect, which we feared would not be sufficient for the application, is actually quite sufficient. Some of the challenges that we are facing right now are not of software nature, but rather they are mechanical. That is, if we improve the mechanical components that we are using for tracking the needle and the probe, that is the markers and the associated equipments, then the accuracy of the motion tracking module can be improved a lot more. Further improvement can also be done in visualization of the needle so that it corresponds to reality. And finally, we can develop the needle placement training in the form of a game so that new anesthesiologists can assess themselves and they can improve their accuracy with time. Thank you.